Last session, last class, we have discussed about three concepts, right? Is TP, TP, IVR. Dynamic trunking protocol, VLAN trunking protocol, inter-VLAN routing. So first one is dynamic trunking protocol. So for that scenario, this is the scenario here. The switch A has some VLAN 10 users, VLAN 1 users, VLAN 20 users. Like three VLANs, three broadcast domains are available here. Even the switch B also have three broadcast domains, which is sales, HR, and admin, VLAN 1, VLAN 10, and VLAN 20. From switch A to switch B have connected one cross cable from port number 21 to port number 18. Now to enable communication between the switch A and switch B, we can use any port. Like port number 24 to 24, port number 1 to 1, not like that. You can use what? Any port to any port actually. But my example here have used 21 and 18. So as we have discussed, what is the default mode of the Cisco ports? The Cisco ports are, it can be access port, or it can be trunk port, or it can be dynamic desirable mode, or it can be dynamic auto mode, right? So what is the default mode? Default mode is a dynamic auto, right? So means port number 24 of the switch A is a, sorry, port number 21 is a dynamic auto. Even the switch B port number 18 also, default mode is what? Dynamic auto. If two sides, dynamic auto and dynamic auto, now this link will be trunk will form or is access link. Dynamic auto is doing is what? Is passively waiting for negotiation messages. Even the other switch also, dynamic auto, is also waiting, right? So two switches, two ports are passively waiting to receive the negotiation messages. Then which switch can provide the negotiation message here, right? There is no switch. So means this link allows which VLAN traffic here. Only VLAN 1 traffic only can pass through this link. So when port number 24 can allow the multiple VLAN traffic, now this link has to configure what? Trunk. But if switch A is a Cisco switch, if switch B also Cisco switch, the both sides now no need to configure trunk. Like what we do is, so one side, if we configure dynamic desirable, if we configure dynamic desirable, then one side is dynamic desirable, one side is dynamic auto. So it's actively initiating the negotiation messages, is passively waiting it, the link automatically will form, right? So this is the protocol is DTP, dynamic trunking protocol. The next scenario, like in multiple switches, multiple VLANs we need to create. Instead of creating the multiple switches, multiple VLANs, like enter your network, throughout your network to maintain the same VLAN information. Like throughout your network to maintain the consistency of the VLANs, then we can use called a protocol called what? VTP, VLAN trunking protocol. The VTP modes are server mode, client mode, and transparent mode, three modes. So by default, all switches are in the server mode, VTP server mode. Like let me keep one switch in the server mode and remaining if we changes the client. Now if we create VLANs or if we delete VLANs in the server, what server switch is doing is going to advertise the same information to the client switches. And what client switches will do? So to copy the information. So server switch and client switch to synchronize the information. So server switch domain name and server switch password should be same for all client switches for security reasons. Right? So once password and domain name is matching, now what client switch is doing is going to synchronize the revision numbers. And VLANs are being copied. Like after that, what client switch will do? The same information will be advertised to next switch. The next switch also can be say the So domain name and password is matching, and then you copy. You can create VLANs, you can delete VLANs, you can modify VLANs in only in server mode. When the switch is in a client mode, we cannot create, we cannot delete the VLAN. Transparent mode is a similar to server switch. We can create VLANs in transparent, and even we can delete also, but local VLANs only, local switch only. So this is how VTP protocol is working. The next topic we have discussed about how to allow different VLAN traffic, one VLAN to another VLAN. So forwarding traffic from one VLAN to another VLAN, this process we call what? IVR, inter VLAN routing. Inter VLAN routing can done in the three ways. The first one is what? By using a router, multiple physical interfaces. Here you can allow the different VLAN communication. The first method. So for first method, we have to use number of switch ports. We are losing number of LAN ports, I mean router LAN ports, number of cables are required. The second method is by using router only one physical port by creating multiple sub interfaces. The third one is a router is not required if the switch is a layer 3 switch, right? Inter VLAN routing, or we can call it as a router on a inter VLAN routing is the process of forwarding traffic from one VLAN to another VLAN by using a router. By using router, multiple physical ports also can do, or by using router one physical port by creating multiple sub interfaces, right? So do you have any doubts yesterday topic, guys, about distance vector like VTP, DTP, and IVR? Clear about all those things? Do one thing. Today, let me start with one scenario here. Network topology here. Question number one is here. Total, how many number of devices are available in this topology? How many number of devices are available? Okay, six devices. Right. Out of six devices, how many are routers? How many are switches? Four routers and two switches. Okay. Yeah, tell me, guys, how we can tell four routers, two switches? How we can say four routers are there and two switches is there? In the packet traces software by symbols, by seeing the symbols, so like the icons, we can identify, right? This is the icon of a router. This is a symbol of the switch, right? Okay, in this topology, okay, but what about your real time? Like you're working in an office. In your office have a one switch. For the switch, how many routers are connected? How many switches are connected? How we can understand it? Simply, this is a switch, but we don't know. So for this switch, how many devices are connected? We can able to see only what cables are connected. Port number one cable is connected. Port number two cable is connected. Port number three, like number of cables are connected. So now tell me, guys, for this switch, how many devices are connected? by seeing the ports and cables, okay, 7 devices are connected. You are saying that by seeing the cables, right? So now you tell me for this switch, how many routers are connected? How many switches are connected? Can you say it? The packet is a software by seeing the symbol. Okay, fine. You are telling is say 4 routers and 2 switches. What about the real time? You will go for packet tracer software example only. You are telling is that 4 routers are available and 2 switches, right? Okay, no problem. Like out of 4 routers, first router and the switch, which port number is connected? First router, R1 router. In a switch, which port number is connected? Router, which model number router is this? And what will be the router IP address? And what will be the router iOS version? For router, LAN port is a Ethernet port or fast Ethernet port or gigabit port. Like how we can get this information actually? Very, very important. It's very useful in the real-time scenarios to know the information. So to discover the information about connected devices, if all devices are Cisco devices. So by default in the Cisco device, you have one protocol is being enabled, one protocol is running. So that protocol is a CDP, Cisco Discovery Protocol. So what the CDP is doing is, the CDP is going to discover which Cisco devices are connected and which port numbers are connected and router host name, router IP address, like device information, like all about devices, software and hardware information will be exchanged, will be advertised. So CDP is already enabled in all Cisco switches. So we don't need to enable it. We don't need to configure it. If you purchase one Cisco device, so I'm telling is here Cisco device. I'm not mentioning any Cisco routers only or Cisco switches only. Like any Cisco device, this protocol is working. I mean, Cisco router, Cisco switch, Cisco firewall, IP4, like any Cisco wireless devices, like all Cisco devices, CDP is being enabled by default. So just you purchase one brand new router and connect it to your network, connect to your network. So between the device, Cisco device to Cisco device, this L1 means layer 1 cable is okay. Cable is properly working enough. Like after connecting your cable, within 60 seconds, switch can come to know about this router information. Now router will come to know about this switch information. So we don't need to configure anything here. So just between the Cisco device to Cisco device, if the cable is okay enough, within 60 seconds, so both devices can exchange the information. Like what information they can exchange? Device a host name we can come to know, and device IP address also you can get, and device iOS versions also can get, and device platform, like which model number it is, a 2800 or 2800, and the interface type. I mean, is a fast Ethernet or gigabit Ethernet, an interface number, port number. Port number 1 is connected, port number 2 is connected. The details information in 60 seconds, like enter the network, device can be exchanged. So how they are going to discover means based upon one protocol call is what? CDP, Cisco Discovery Protocol. So name itself is telling is what? Cisco Discovery. So it is Cisco proprietary protocol. CDP is enabled by default in all Cisco devices. Advertisement for every 60 seconds. So these advertisements will send by using multicast address is what? 0100. This is a multicast address. You can copy. The point here. Advantage of CDP. Once layer 1 is active, CDP sends information to its active neighbors. When if we take the topology here, consider switch A and switch B. Switch A, how many devices are directly connected? Switch A, how many devices are directly connected? 4 devices. Means out of 4 devices, which device links are being active? You can see the port LED's color. The green one is also green, right? Now switch A CDP is going to discover only R1 device 1 information, device 2 information, and switch information only can be discovered. But even one more device has been connected, but the cable is what? Not active. Right? The point. CDP can send the information to it active neighbors. The neighbor should be active. Active means what? Layer 1 if enabled enough. The cable is enabled enough actually. Okay. But one more point is here. For A router, like switch A, 3 routers, one switch is connected directly. For switch B, how many devices are connected? Only 2 devices. One router and one switch, right? So CDP can discover only directly connected devices, only can discover. So now switch A can discover only directly connected, like even switch B also. Not indirectly connected device. Let me show you. The packet is a software. Let me log into switch. In privilege mode, just use the command show CDP. LAN to Chennai, Hyderabad. So first information we got about what information, guys, here. Host name. Host name we have verified. The next one is a local interface. So LAN to device connect to which port number? Port number 4. Chennai device connect to which port number? Port number 1. Hyderabad device connect to which port number? Port number 2. So by seeing the host names LAN to Chennai or Hyderabad, can you define which is a router, which is a switch, how many switches, how many routers? So by seeing the host name, we cannot tell, right? Then how we can identify, so which one is a router, which one is a switch means capability of the device. Is the capability here clearly showing is a S indicates switch or indicates what? Router. Okay, switch is connected. Which platform? What is the platform of the switch? So 2960 switch is on my network. 2600 routers in my network. 2800 routers in my network. We are getting a hardware platform information. And interface number also have verified. Thing is CDP is telling is that you can get IP address also. You can get iOS information also. An interface type is Ethernet or fast Ethernet or gigabit Ethernet also you can get. Like how you can get information is the same command to CDP neighbor details. So once if you show CDP neighbor detail LAN 2 IP address 10.10.10.1 is connect to fast Ethernet port number 1. Capability of device A switch. And the switch iOS version is 12.2 iOS version. The port is being supported for what type of duplex communication is a full duplex is being enabled. Like device to information. Host name is Chennai. IP address is 10.0.0.1. It's a 2600 router. Capability is a router. All the information you can get. Two comments. Show CDP and show CDP Show CDP neighbor, show CDP neighbor detail. We have one problem in this protocol. We have one vulnerability. What is that vulnerability? So we need to configure CDP in any devices. Cisco device, we need to configure it or no need to configure? No need to configure, right? Because it's already enabled. So this is my organization network. An unknown user. Unknown user means hacker is being connected. Now hacker device is a D-Link device. So what hacker is doing is he connected to my network. So my switch is what? Cisco switch. Hacker switch is a D-Link switch. Now hacker can get my switch A information. So why? Because CDP protocol can work in only, can discover only, can forward information only for what? Cisco. You know what happened now? What hacker is doing is he went to market and he purchased a Cisco device. He purchased what? Cisco device. Now hacker required any passwords? Hacker required any configuration? Nothing. He just connected a Cisco and connected to our network. Now within 60 seconds, the hacker will come to know switch A. What information, guys? Within 60 seconds, so hacker will come to know about what information of the switch. Host name of the switch, IP address of the switch, iOS version of the switch, switch is a which model number. Yeah, even like all the information about the switch within 60 seconds they can come to know, right? This is the problem. This is the vulnerability of Cisco devices. How we can overcome this type of issues means we can disable the CDP. By default, CDP is enabled, but anyhow we can disable it. Like I'll tell you first how to enable it. If already disabled, I'll tell you how to configure CDP. Router configuration mode. CDP run. Run. So now you tell me guys how to disable it. In the router also or switch also. Any device. How to disable it? Perfect. This add command is what? No. No CDP run. So what exactly I'm doing is, what are the chances are available for attacker to connect to my network? Maybe there is a chance for port number 8 or port number 9 or port number 11. So selected ports, I'm going to disable CDP. I'm going to enable this command. If you disable the CDP, now even attacker is been connected, no use of it. He cannot get the information, right? We can enable CDP. Default is enable, but you want to disable, you can use this command. No CDP run. So command is CDP run. No CDP. Now verification commands. No CDP. No CDP neighbor. No CDP neighbor details. All devices, not only inside the switch, Mustafa. You can use in like any all devices. Cisco, any Cisco device, switches, routers, firewalls, like any device, you can enable it. You can use these commands. Want to enable CDP run. Want to disable, no CDP run. What are the drawbacks of the CDP? Yeah, if you use CDP run, it's going to affect all the ports of the device. The switch has a 24 ports. If you use CDP run, 24 port CDP is enabled. If you use a no CDP run, 24 ports CDP is disabled. Let me show you the practice here. No CDP neighbors, you get neighbor, right? Now what I'm doing is no CDP run. If you use the show CDP neighbor, CDP is not enabled. How many ports? Like all 24 ports, CDP is disabled. And what I'm doing is CDP run. Now all 24 ports CDP is enabled. Selected ports only want to disable CDP. You can go for respective ports. Interface, pass Ethernet, port number 8. No CDP enable. No CDP enable is the command. Now port number 8 only the CDP is disabled. Remaining all the ports the CDP has been active. Or even you can use some range of ports also. Interface. Range. Pass Ethernet 0 slash port number 8 to port number 19, 8 to 19. No CDP enabled. Now port number 8 to port number 19, CDP is disabled. What are the drawbacks of CDP? Disadvantage of CDP. Directly connected details information only can get. Okay, 1 point. CDP can discover only Cisco devices. In your network, in your real time, maybe can have a Cisco device and non-Cisco device also, right? But CDP can discover only Cisco device only. What about non-Cisco devices? To discover the non-Cisco devices, still we have one more protocol, is LLDP, Link Layer Discovery Protocol. Link Layer Discovery Protocol, LLDP. CDP is a Cisco protocol, LLDP is a open standard. CDP can advertise information for how many seconds? One L1 is active. Within how many seconds they can advise? 60 seconds. If it's LLDP can discover within a 30 seconds. CDP can discover in how many seconds is a 30 seconds. This is a Cisco protocol. LLDP. LLDP is a open standard. And within 30 seconds it can discover the neighbors. Verification commands of LLDP. Show LLDP neighbor. Show LLDP neighbor detail. Same verification commands. Even the configuration also. LLDP run. No LLDP. So only major difference is CDP is already enabled, but LLDP had to enable it by using this command, LLDP run command. Okay, guys? So these protocols are very useful to get the neighbors information in their real time. CDP, LLDP. Yeah, we need to enable in all switches LLDP. LLDP is disabled by default in all Cisco switches. We need to enable it. So you just execute the command in also all switches. LLDP run. No. It does not work like a server and client. Manually, we need to enable it. See, there's a reason which switches you want to enable. The switches only can enable it. So otherwise, if it's a server and client like mode, if remaining all clients are being enabled, the attackers can get the information, right? So manually, we have to select which switches have to run LLDP or CDP, which switches have to remove CDP. We have decided. Manually, we need to maintain it. Okay, guys. LLDP IEEE standards 802.1 AB. Right. So now these are all the topics of today. CDP, LLDP. Any doubts about this topic? No doubt, right? Okay. What was the time now exactly? 2:45, right? Can you hear me, all of you? So mostly they're 2:47. So I request to all of you take white paper and pen. Now we are going to discuss, which is very, very, very important topic. The switching, the most important topic. So try to make you comfortable. Take pen and paper. Just wait for a few minutes. Ready? And I'll give the 3 minutes only. 5 minutes. Exactly. Fine. Okay. Right. Yeah. Can you hear me, guys? Already? So first, understand the scenario clearly. If it is possible, try to copy the diagram also. Switch A. The first switch name is A, switch A, and second switch name is A, switch B. In switch A, you have a 24 port switch, and the switch B also 24 port switch. Port number 1, 2. Right. 24 port switch now. Now have one device connect to port number 3 in switch A, port number 4, port number 5. Some devices are connected. In switch B also have some devices like a organization servers are connected here. Is my mail server, and we have a file server, and maybe your DNS, DHCP, whatever server is here. So here my simple question is, now out of two switches users, switch A users and switch B users, which switch user can access mail server and file server? Switch A users or switch B users? Switch B users only. Then how can allow switch A users also can access the mail servers and file servers? I mean to say how to enable communication between the switch A and switch B users. Uplink between the switch to switch. So which cable we use? RJ45, a straight cable or cross cable? So straight cable we use for connecting different type of devices. Cross cable is for what? Same type of device like a switch to switch. Now I'm taking one RJ45 cross cable. So that cross cable from which port number to which port number we need to connect? Port number 24 to port number 24? Or port number 7 to port number 7? No, not like that, Sunesh. Like generally, preferable is 24, 24, but the thing is what you can use any port to any port. Now, my example is I'm connecting from port number 1, port number 1 to port number 1, right? So cross cable is connected. So now you tell me, guys, switch A users can communicate to switch B users, or we need to configure any trunk required here? Trunk is not required. When trunk is required? When the link is carrying more than number of VLANs, multiple VLANs, right? But here we didn't define any VLANs. Means default VLAN 1. Only cross cable is enough. Okay, right. Single VLAN traffic. Now switch A users, switch B users can communicate. So now you understand switch B in a ground floor in my office building, switch A is in my first floor. So they are communicating like this. After some time, now main scenario will start it. Listen carefully. Like after some time, link between switch A and switch B is been failed. Then what happened, guys? If link is been failed, now switch A users can communicate to mail server, file server, no communication, right? Connection is being failed. So users are being complained. Users started complaint to network administrator. Hello, network administrator. We are not able to access file servers and mail servers. What network administrator will do, will find the where is the problem. After some time, he find out, okay, A and B switch link is being failed. How much time will take to make a one new cable from first floor to second ground floor? Approximately, how much time will take? 1 hour, 30 minutes or 1 hour, right? So means up to 30 to 30, like 1 hour, up to 1 hour, there is no communication from switch A to switch B. 1 hour you have the downtime. So now you understand switch A are complete all public users, means we are connected. The switch B is a Google server. The link is been failed. Now tell me, guys, what happened? How much? Like how much the transactions is being stopped? How much communication is being stopped? So what I'm telling is here, this type of network issues are single point of failure. So there is no backup, there is no redundancy here. Like A and B users are connected to via only one link. If the link fails, no communication. And we need to wait for 1 hour or 1 day also or 2 days also, whatever, right? Here, so first try to understand importance of the backup, importance of the redundancy. In generally, if you go for anywhere, we used to take what? Backup, redundancy. Normally your certificates, normally your ID proofs also will do what? Will make one color xerox in the backup for this, right? Redundancy. Anywhere we require what? Redundancy. The production environment also, switch A and B users have the only one link. If it's a fails, no communication. So to avoid single point of failure, to eliminate single point of failure, so what I'm doing is, as a good network engineer, I suggest to my network is, I'm making one backup link. Right. Let me make one backup link. So this link I'm connecting from port number 24 to port number 24. So why the second link is required? Backup purpose. Whenever first link is being failed, now without any downtime, A and B users can communicate via another link. So this type of topology we call redundancy topology. So now you tell me guys, what is the good advantage of redundancy topology? Backup is there, right? Backup, no failure, no single point of failure. Even the link is being failed, so still we have communication without any downtime. So in the real time, which topology do you refer? Which topology do you recommend? Single point of failure topology or redundancy topology? Redundancy topology, right? Perfect. So what I'm telling is, you also try to design your topologies like what? Redundancy always. Backup is must. Okay. So very good advantage of this topology is a redundancy available. But you know what happened? When you connected the backup link, now some new problems will come in the picture. So in one angle, we are telling is what? We have very good advantages. Backup is available, the link fails. But thing is what, some new problems will come in the picture. What was the problem? The problem is switch A maintains a MAC table, switch B maintains a MAC table, right? What is the default MAC table is what? By default is what? MAC table empty. Router FE, fast Ethernet 0/0 and switch ports. So basically, first let me see the difference between router ports and switch ports. Can you define the command how to configure the IP address to fast Ethernet port? What was the command? Assign the IP address to fast Ethernet. Interface FE 0/0 IP space, address space, IP address, and subnet mask, and no shutdown. Why no shutdown command? So why? Because router ports are by default is a shutdown state, but switch ports are not like that. So we have configured any interface fast Ethernet 0/1 no shutdown, 2 no shutdown, 3 no shutdown. We don't do right. No, why? Because switch ports by default is a forwarding state. Only router ports are shut down. Now our scenario is here also. Switch A and switch B, all 24 ports by default is what? Active, means forward state. So port number 1 is forward state. Port number 2 is also forward. 3 also forward. 4 also forward. Even port number 4 is a forward state. What about switch B? Port number 4, forwarding state. Switch B, port number 1, forwarding state. Clear? Are you getting the point? Hello? Hear me, guys? Right. Yeah. Let me explain one. Router ports. Router ports by default is a shutdown state. To activate it, we use command is what? No shutdown. Then it will become what? Up. But switch ports are like 1, 2, 3, 24 ports. Once you connected a computer, we no need to give the command no shutdown for port number 1. No need to for no shutdown for port number 2. So once you connect the device, is activated. That's it. In short form, I'm saying is what? Forwarding state. So by default, all the ports are what? Forward state. Clear? Mustafa is clear? Right. Okay, now switch A maintains the MAC table. Switch B also maintains the MAC table. So default MAC table is what? Empty. Now first user is trying to communicate with second user. If MAC table is empty, like destination MAC address is not in the MAC table, what switch will do? What type of communication started now? Unicast or broadcast? Broadcast. Now broadcast to which ports? Port number 4, port number 5, port number 7, port number 24 as well as port number 1. Now port number 24 state is what, guys? Port number 24 state is what? Forward. So the same broadcast packet is being forwarded to switch B 24. Switch B port number 24 state is what? Forward. The same broadcast packet for broadcast to all 24 ports again. Even port number 1 is also been received. Now port number 1 state is what? Forward. The same broadcast packet forward to A. The port number A, switch A, port number 1 state is what? Forward. Again forward to 24, forward to 21. Forward, 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 forward. So continuously, only one broadcast packet is being forwarding. This is very impacting your land. So this continuous broadcast making your whole complete network is being down. All ports are busy with the broadcasting. All the ports, 24 plus 24, A and B. Like two switches, ports are busy with what? Forwarding, 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 broadcasting, broadcasting continuously. Very fastly broadcasting, continuous broadcast. So when continuous broadcast happen, then how the end users can extend the data? Now, when end users are sharing the data, our ports will say, hello, end users, we can't share your data. We are very busy now. I'm dropping your traffic. See, it's very big problem right now. Like even the users cannot be able to communicate. Your complete network is going to down. Let's say first computer MAC address is A1. So this MAC address will be updated here. The same time will update here. Again update here. Again update here. You know why? Why? Because continuously broadcasting. Even your MAC table is not stability. Instability of MAC address. Now broadcast coming from port number 24, again port number 1. Again port number 24, again port number 1. It's multiple frame copies. It's all the information collectively we call layer 2 switching loops. Layer 2 switching. So this is a problem with what type of topology? So loops are forming in what type of topology? Single point of failure topology or redundancy topology? Redundancy topology, right? If it's a single point of failure, no looping, no loops. When you connect the multiple links first between the switch to switch, so problems will come in the picture. So those problems we call what? Loops are being forming. So loops means what? Continuous broadcast, multiple frame copies, MAC table instability. So these all we call layer 2 switching loops. Okay. Our main concept is how to stop these loops. If you are not stopping the loops, what happened? The complete network is going to down. So we need to manage the loops. As a network engineer, we have to understand how the loops are forming and how to prevention it and how to stop it, how to avoid it. So this technically we have to understand clearly. Let me go for solutions. Can you answer? What was the solution number 1? How to stop loops? Any solutions? See, if you understand why loops are forming, then you can get the solutions. So first try to understand why loops are forming, how loops are forming. When loops are started, remove cable. Oh, have remove the cable. One cable has been removed. If we remove the cable, they have the loops are forming, guys. No loops. So solution is what? You have to stop loops. Stop loops. So solution number one is a remove link. If you remove the link, no loops. The same time, what happened? No redundancy also. We clearly already discussed the importance of redundancy. So redundancy is a mandatory in the production network, right? So if I connect a link, then what happened? Again, loops are formed. If I remove the links, no problem. No loops. The problem is what? Single point of failure. So redundancy is must. Remove link is not a proper solution, right? Solution number two will go. Single time loop. How we can set it? No, no, no. It's not possible. Single time. You need to stop only. You need to avoid the loops only. Okay, Ram. The first thing is remove the link. If you remove the links, loops are forming, stopping. But at the same time, what? We don't have a redundancy also. And someone is already messaged. I think Pradeep. I think so. Yeah, Pradeep. Port shutdown. Good. So switch A port number one, R24. Switch B port number one, R24. Any one port you can do the shutdown. Example, interface, fast Ethernet, 0/0. Command is what? Shutdown have executed. Not 0/0, sorry. Port number 0/24. Switch A or B, anyone. Example, A switch. Now switch A port number 24 is a shutdown now. If port number 24 is a shutdown, now do you have any loops here? Is there a chance for looping now? No loops, right? Yeah, exactly. So now we have stopped the loops. So now you tell me, guys, how switch A and switch B users can communicate via first link or a second link? Via which link A and B users can communicate via first link? Okay, now A and B user communicating via first link. After some time, if first link is being failed, A and B users can communicate? No. Again, your LAN users has to raise the ticket for network engineer. Hello, network engineer, we are not able to access my mail server. The network engineer has to identify, okay, one link is been failed. Now, what network engineer has to do? Now, network administrator has to do what? No shutdown. Log into A, interface fast Ethernet 0/24, no shutdown. Then, your port number 24 is being, will come forward state. Now, they can communicate via second link. It's also is making time, right? It's also it is taking some time. Okay, fine, no problem. After some time, your first link is being activated. Then what happened again? Loops. How to stop loops? Again, what will you do? Again, execute the command is what? Shut down. Again, one link has been failed. Then what will you do? Again, no shutdown. So this is the problem with the shutdown command. It's also not a reliable step, right? And what is the best solution? The best solution is we required one protocol. We need one protocol. If you use one protocol, you know what the protocol exactly is doing is this protocol is going to making your port is a block port. The protocol is not going to making your port is a shutdown. It's doing is what? Your port is being disabled. Your port is being what? Block state. It's temporary block, alternately blocked. If port number 24 is blocked means no loops. Now you tell me guys, A and B users can communicate via which link? First link. So whenever first link is being failed, what protocol is doing is within a seconds, without involve any network engineer. So what protocol is doing is, okay, first link is being failed, within a seconds, your block port automatically become what? Forward state. Now users can start communicating via second link. Now users also without any knowledge. So users don't know about we are communicating via first link or maybe second link. First link is down, we are going to second link without any knowledge. This protocol is going to manage it. Forward. Like after some time again, your first link is been activated. Now loops are started, right? What again protocol is doing is to avoid the loops, again is making what? Block. Is it best option or not? This protocol is STP, spanning tree protocol. So now you tell me guys, what is the use of spanning tree protocol? What is the use of STP protocol? So spanning tree protocol is used to avoid layer 2 switching loops by blocking a port in which topology? In redundancy topology. So this is a single statement about a spanning tree protocol. If someone is asked about a spanning tree protocol in interviews, so we need to say the answer. So spanning tree protocol is used to avoid layer 2 switching loops by blocking a port in redundancy topology. Like how exactly a spanning tree protocol is going to stop the loops? By blocking a port. In which topology port is being blocked? When you have the multiple links, block port is required, right? So once you have the multiple links, this type of topology we call what? Redundancy topology. Okay. You can see here. To eliminate single point of failure, backup links are being used. This type of network topology called what? Redundancy topology. The users are communicating to server via only one link. Is the link? If the link is being failed, no communication. So to eliminate this, backup links are being used. So once you have the backup link, so what are the problems? Problems in redundancy topology. What are the problems, guys? Multiple frame copies. Multiple times frame copies is a active instability. So switch A, switch B, A and B again and again. And multiple frame copies and broadcast terms continuously broadcast. So these all collectively we call the layer 2 switching loops. So to stop the layer 2 switching loops, to avoid the layer 2 switching loops, we use protocol. That protocol is what? STP, the spanning tree protocol. Okay. So we required very good knowledge about spanning tree protocol terminology. How it is going to block the port? What is the process is going to block the port? Once port is being blocked, how the port protocol come to know a port is being disabled or link is being failed? How much time it take to activate the block port to forwarding state? These are all the mechanism. So today we are going to discuss clearly about STP protocol. Are you ready? So first solution is not required. Remove the link is and shutdown is also not required. And what is the best solution is the protocol. That protocol is STP, spanning tree protocol. Did you copy that diagram? When the solutions also like remove link, shut down. Good, good. Okay, let me start about STP protocol. By default, port number 1, port number 24, like all ports, what is the state? Forwarding. So to stop the loops in this topology, we need to configure what, guys? If enable STP, what STP will do? How exactly STP will block the, how STP will avoid the loops? By blocking a port, right? So now STP is going to block which port and which switch? In switch A, port number 1 or port number 24? In switch B, port number 1 or port number 24? So which port is being blocked by STP protocol? That is the main question here. We should tell. Oh, okay. Actually, we don't need to tell it. So STP automatically will choose it. When we can tell also. Now how, what STP is doing is to block the port, STP is going to do some elections process. STP election. So STP elections based upon the 4 parameters. Point number 1 is the first one is the root switch. The next one is STP is going to elect the root port. And STP is going to elect the next one is a designated port. Last finally, STP is going to elect one more is a non-designated port. So the switch, which switch is being elected as a root switch. So that root switch ports always in forward state. STP will not block the root switch port. So which ports are elected as a root ports? STP will not block the ports. So this is always forwarding state. Like which ports are elected as a designated ports? Designated ports also forwarding state. STP will not block the ports. So finally, which port is elected as a non-designated port? So that port is being blocked by STP protocol. Non-designated port is a block port. So let me explain clearly about what is a root switch and how to elect as a root switch. What is the parameters STP will consider to election the processes. The first one is out of all switches in your network. Out of all. So here my example is switch A and switch B. In the real time, you have number of switches, right? Like out of all switches in your network, only one switch is elected as a root switch. So that switch we call focal point of the network. So in your organization, in a network topology, you have a 10 switches. Out of 10 switches, one is a root switch, remaining all are non-root switches. I repeat once again. Out of all switches in your network, only one switch is elected as a root switch. So that root switch is a focal point of the network, head of the network. Right? So in our topology here, switch A, switch B, two switches, right? Like out of two switches, which is a root switch, A or B? Like in my office, I have 10 switches. Out of 10 switches, which is a root switch? Switch 1 or 2 or 3 or 4 or 9 or 10, which one is a root switch? Out of 2, 1 can be either A, either B. Out of 10, 1 only. Which is a root switch means switch with best switch ID will be a elect as a root switch. Switch with best switch ID. Again, the question is what? What is switch ID? What is switch ID means each and every switch has a priority value. Unique ID called what? Priority value. In STP case, so V switch has a lowest priority, that will be the root switch. Least is the best here. Lowest is a best. Let me take one example. Default priority of switch A is a 32768 is a value priority number for STP. 32768. If switch B priority is a 32767. Now switch A and switch B out of two switches, which is a root switch? A or B? Switch B is a root switch. Why? Because lowest priority, right? Okay. The point is switch B priority also 32768. Now you tell me guys, out of two, which is a root switch? Switch A or switch B, which is a root? Why A? Why not B? Starting first is A, the reason, right? Not like that. When priority is the same for all switches. If priority is the least and highest, the least will be wins, right? But when was the problem? When priority is the same for all switches. Now what STP is doing is, now let me consider, you have all the priorities the same, right? Now let me consider MAC address of the switches. Switch MAC address. So which switch has the lowest MAC address? So that will be the root switch. When MAC address will come in the picture, guys? When priority is a same, then only MAC address will come in the picture. But generally, root switch. So STP is going to elect as a root switch based upon what? Priority only. So when MAC will be come in the picture means if priority is the same, go for MAC address example 001 and switch B is a 002. Now tell me guys, which is the root switch? Switch A, right? So switch ID means a combination of priority plus MAC address. Okay, clear guys? Now here, switch A is elected as a what? A root switch. What about switch B? Other than root switches, remaining all switches are non-root switches. You can see here the first point is root switch. Switch with the best switch ID. Out of all switches in the network, one switch is elected as a root. The root become focal point of the network. Each switch has a unique identifier called what? Bridge ID, or we can call it switch ID. What is switch ID? Switch ID is a first one is what? Priority. If priority is the same, MAC will come in the picture. The lowest priority wins or highest priority wins? Lowest priority wins, right? And default priority value is what? 32768. Now, in my network, in my organization, I have a 80 switches. Total how many switches, guys? Total are 80 switches. Now you tell me, out of 80, how many are root switches and how many are non-root switches? Out of all, out of all switches in the network, one switch is elected as what? Root. Only one is root. All switches other than root switch, we call is what? 79 are non-root switches. Okay. Is it clear, Nikhil? Everyone clear? Are you getting the points? Now let me check from your side. So this is a task for you. Right, all of you be ready. This is a task for you. Switch A and B connected via port number 2324. A and C connected like this, and B and C connected like this. Is a redundancy topology. Now out of three switches, A, B, C, three switches. Which one is a root switch? Can you say which is the root switch? A or B or C? What is the switch ID? Very good question. If you don't know switch ID, can you define the which is the root switch? Is it possible? No. Okay, let me define the switch ID. Switch A priority is a 32768. Now tell me, guys, which is the root switch? What is Sunish? Yeah, exactly. So now you're asking about B and C information also. Now we know only about 32768 about switch A. We don't know about what? B and C, right? How we can decide? Maybe B has a highest or maybe lowest. Maybe C has a highest or lowest, right? We don't know. So we cannot say which is the root switch. Okay. Let me define switch B priority is 32768. Now, which is the root switch? Still we can't say, right? So we require the C information also. Now switch C priority is 32768. Now you tell me, guys, which is the root switch? Yeah, we can't say still, right? So what does it mean means? Like we require all the switches information. We need to compare it. Now priority is the same. So now we are going to looking for MAC address. Let's say now MAC address required for only one switch or three switches MAC address information is required. Three switches MAC information. So switch A MAC address is 001, switch B is a 002, and the C is a 003. Now you tell me, guys, which is a root switch? Perfect. Switch A is a root switch. So how we can tell switch A is a root switch means we are going to compare of the switch A priority, switch B priority, switch C priority, and all are the same. Again, we are going to compare A MAC address, B MAC address, and C MAC address, right? So by seeing the network diagram, we can decide it. But now you tell me, guys, how switches will come to know about this information? So only switches are connected via cable. Like how switch A will come to know about B information. Like how A will come to know about C information. Like each and every switches, how they can come to know. Don't know other switches information, right? So you know what will happen here? Switch A is telling is that I'm a root. Switch B is telling is that I'm a root. So switch C is telling is that I'm a root. Like each and every switches, their own feeling is what I am a root. I am a root. Then what happened here? If all A and B switches are root switches, now you tell me guys, then what happened? No, not collision. No. If all are root switches, what happened, Mustafa? Perfect. Loops are forming. Why? Because a root switch ports always state is what? A root switch port state is what? Forwarding state. So means switch A port number 23 is a forward. Switch A port number 24 is forward. Like is also root switch. Forward it. Forward it. Like all ports are forward state means. Then what happened here? Loops are been forming. Going to making your complete network is down. So guys, we can stop the loops. Election process has to do. We require the root switch election. We require the non-root selection, right? So election process has to do means you know how like A should know about B information and C information, how to compare it. And B should know A information and C information and B have to compare it. And C should know A and B information. Like after that only root switch election, root port elections, designated port, non-designated port, block port, then loops are being stopped. So how switches will come to know other switches means, so this is very important. The backbone of the STP protocol, the key point of STP protocol means if we enable STP in A and B and C switches, what three switches is doing is they'll start exchanging hello packets for every 2 seconds. A, B, C, three switches exchanging what? Hello packets. Similarly, hello packets, but technically we call it is a BPDU packets, Bridge Protocol Data Units. Like inside the hello packet, I mean inside the BPDU packet, like switch A priority value, switch A MAC address information, like all those things is being involved. Now what it's doing is sending, exchanging hello switch B, my BPD packet. So what B is doing is my BPD packet, like all are being exchanged. Now A will compare. So B priority and C priority. Now A is telling is that okay, we have same priority values. Again, we'll extend the MAC address. Now A is telling is that my MAC address is 001, your MAC address is 002, your MAC address is 003. So I have the lowest MAC address. I'm going to become the root switch. Now what B is telling is that so my MAC address is 002, your MAC address is 001. Okay, you have the lowest MAC address, you will be a root switch, I'll be the non-root switch. Now you tell me guys, so how exactly STP is working? How STP is going to do the elections? So completely STP protocol, the main mechanism is based on what? BPDU packets. Bridge protocol data unit. The scenario here. Which A is telling is what? I'm root. I'm root. Why they don't know other switches information? Like how switches will come to know other switches information? How they can come to know, guys? By exchanging video packets. Yeah. Similarly, hello packets or BPD packets technically. The BPD packets are being started. They're exchanging now. After exchanging the BPD packets, B is telling is that I'm root. C is telling that I'm non-root. A is saying that I'm root. Clear? Here, BPDU, Bridge Protocol Data Units. BPDs are sent every 2 seconds. So based upon the BPD contain information, we are going to determine devices, switches are going to determine priority values, MAC address information, how they are connected, which port numbers are connected, all the information based on what? BPD information. Right. Here have one small question. Let me ask it. Switch A and switch B. Number one, port number one. The first one link is connected. Port number 24 and port number 24. Second link is connected. Now, when we have a multiple links, loops are being started. To stop the loops, we can enable protocol is what? STP. Now, what STP will do? Will block the port to stop the loops. Let's consider port number 24 is a block port. BLK, block port. This is blocked by STP protocol. Now, switch A and B users can communicate via which link? Via first link, right? First port. Now, after some time, if link is being failed, first link is failed, a block port automatically become what? Forwarding state, right? Here I have two questions. Question number one is, how block port will come to know first link is being failed? I repeat once again. How block port, like switch B port number 24. So how block port will come to know first link is being failed? That's question number one. Question number two is like after is a link is being failed, block port to become the forwarding state. How much time will take? The initial question is how block port will come to know first link is being failed. After link is being failed from block port to become the forward state, how much time will take? They come to know sending BPD in every 2 seconds. Yes, exactly, Mustafa. You know how block port will come to know link is being failed. So actually, via first thing, they exchange BPD packet for every 2 seconds, right? If the link is being failed, do you have any BPD packets via first link? No BPD packets. Now, what port number 1 is doing is they'll wait for 10 BPD packets. one BPD packet is a 2 seconds and they are waiting for 10 BPD packets. Means 10 into 2, how many seconds? 20 seconds they are waiting. Like up to 20 seconds if there is no BPD package. Now port number 1 will inform to port number 24. Hello, port number 24. I'm not receiving BPD packets, means my link is being failed. Now what block port is doing is, yes, let me start sending BPD packets to via my link. So what port number 24 is doing is, now port number 24 after 20 seconds will start sending BPD packets. So this state we called LST, listening state. So it starts sending the BPD packets, means listening state. So this listening state will may take time is a 15 seconds, 15 seconds. Like after listening state, now A and B is telling is that now take my priority and take my MAC address. So B is going to learning. That state we call LRN, learning state. So this learning state will take time is what? 15 seconds. Like after listening state and learning state, now your port become what? Forwarding state. So means from block port to become the forward state, well, how much time is taking? Your waiting is 20 seconds. On listening state, learning state, approximately is taking what? 50 seconds time, right? What exactly here? When port number 24 is in a block state, no data communication. Data communication is not possible. So when your port number 24 is in a listening state, no data communication. Communication is not possible. When your port number 24 is in a learning state, data communication is not possible. So when via backup, via second link, when they can start doing communication means your port should be become what? Forwarding state. Then only data transmission can be possible. So as a network engineer, we have to understand what exactly happening in a block port, what happened in the listening state, what happened in the learning state. Right? So once the port will comes like a forwarding, then only data transmission is possible. Let me see clearly about the states. STP port states, blocking, listening, learning, and forwarding. The listening state, forwarding frames means data communication, the short form you can say. Data transmission is possible in the blocking state? No. The listening state? No. Learning state? No. When it's possible, only forwarding state. Then what happened in the blocking state? So when the port is in the blocking state, even your MAC address is not learning. Then it's just receiving BPD packets only happen up to how many seconds is a 20 seconds. The listening state, no data communication, no learning MAC address. Then what happened in the listening state? BPD packets are being sending and receiving both. Okay, so it will take 15 seconds time. And learning state, so here MAC learning is possible. BPD packets are sending and receiving 15 seconds, and forwarding state happen or data transmission, learning MAC address, receiving and sending them BPD packets, and no time, unlimited time. STP port states. Just wait a minute. I'll come back within a couple of minutes. Wait a minute. Okay. Switch, right? And what is the root port? The root switch means out of all switches, one is a root switch. Remaining are non-root switch. And what about root ports? So let me explain clearly about root port. Listen carefully. Out of all switches in your network, only one switch is elected as a root switch. Is it clear? Remaining all are what? Non-root switch. example, I have a 50 switches in my company, in my office. So one is a root switch, remaining 49 are what? Non-root, right? Every non-root switch must have a root port. Every non-root switch must have a root port, but only one port can be a each switch. Each switch, one port can be a root port. Repeat once again. Out of all switches in my network, I have a 20 switches in my network. Out of all switches, one is a root switch. Remaining 19 are what? Non-root switches. Every non-root switch must have a root port, but only each switch one port will be root port. So now you tell me, guys, in my network have a 70 switches in my network. How many root ports will be have? Perfect. How many root ports? One root port. No, no. One is a root switch. Root ports are 69 are root ports. Out of 70 switches, one is a root switch. 69 are non-root switches. Each non-root switch must have one root port. Only one port can be a root port, right? Each switch one root port. And non-root switches, non-root. Here, root port. Every non-root switch must have a root port. Only one port per switch can be a root port. Hello, can you hear me clearly? Hello. Yes, right? Okay. See the point number 2 here. Only one port per switch can be root port. Now all root ports will be in a forward state. So based upon our example here, we have a switch A and switch B. Out of two switches, one is a root, one more is a non-root. So A is a root switch and B is what? Non-root switch. Now we can get the root port in which switch? So root ports we can get only in which switches? Root switches or non-root switches? Only the non-root switches have only what? Root ports. So means switch B must have a one root port that can be port number 1 or port number 24. Either port number 1, either port number 24. Out of two, which one is the root port again here now? 1 can be a root port or 24 can be a root port. So which is a root port? Port number 1. Why, Ram? Why port number 1 is a root port? Why can't 24 port number 20? First port, first priority. Is it like this? Again, election process will happen. Now, root port elections. So root port election means which port is a closest to root switch, nearest to root switch. That is a root port. The root switch is a switch A. Port number 1 is the closest or port number 2 is the closest. So port number 1 is the nearest or port number 24 is the nearest. Based on that, root port. So closest or nearest means what? Let me see now technically. Now port number 1 here is a fast Ethernet. If is also fast Ethernet, if both ports are fast Ethernet, what was the link speed? Fast link speed is what, guys? 100 Mbps, right? If port number 24 of switch A is a gigabit Ethernet, if 24 also, this example, just for example, is also gigabit Ethernet. And what was speed? 1000 Mbps. So which is the closest? Which is the best? Port number 1 or port number 24? If my end user's traffic, if I go via port number 1, link speed is what? 100 Mbps. If my traffic is going via port number 24, link speed is what? 1000 Mbps. So which is the best? Port number 24 or port number 1? Port number 24, right? So port number 24 is become what? Root port. Root space elections based upon the first parameter is the first point is cost, is bandwidth. Now my example here, your first link cost is speed is 100 Mbps. If the second link is cost is also like speed is also 100. Which is the best? Which is the closest? Which is the nearest? Port number 1 or port number 24? Which is the root port now? Can you say it? Which is the root port? No. Because both are same, both are equal, right? When cost is same for two ports, what STP is doing is, okay, speed is same, right? Now, STP can consider next point, next parameter is a neighbor switch ID. Neighbor switch ID. Port number 1, which is the neighbor switch? A is the neighbor. A switch ID is what? 32768.0.0.1. Via fast Ethernet 0/1 32768 plus 0.0.1. If traffic is going via fast Ethernet 0/24 for port number 24, which is the neighbor switch, even via port number 24 also neighbor is what? Switch A, right? So via port number 24 also switch ID is 32768 plus 0.0.1. Even switch ID also same. House is tie. Neighbor switch ID is also tie. Now what STP can consider is finally best physical port numbers. Ram, can you get the point now? Now finally what STP will do? So via fast Ethernet 1, fast Ethernet 24, which is a best port number? Lowest port number is the best, right? Port number 1. Physical port number. So based upon the three parameters, root port elections will be done. Okay, guys? Here finally, switch B, port number 1 is what? Root port. Port with the least cost, port with lowest neighbor switch ID, lowest physical port. IEEE standards, we have some cost values in here. Standard cost value. Fast Ethernet cost is what? 19. Ethernet cost value 100. Gigabit is 4 and 10 gig is 2. Cost is least. Speed is 10,000 Mbps. Cost is 100. Speed is what? 10 Mbps. Least cost, high bandwidth, high speed. Let me repeat again. Root port elections. A is a root, B is non-root, and C is non-root. Like out of 3 switches, how many are root ports? In which switch root ports can have? 2 root ports. In which switches? Switch B must have a 1 and C must have a 1, right? The switch B, either port number 24, either port number 23, right? Or C also, either 23 or 24. How to elect it? Based upon the first parameter is what? Cost value. So from switch B, if any one device is connected, let's consider is a one device connected. From this device, this data traffic to reach focal point of the network, which is root switch of the network. So data traffic to reach root switch, how many routes, how many paths are available? You can go via fast Ethernet 0/1, 0/24, right? FA 0/ via 24 I can reach, and one more is fast Ethernet 23. FA 0/23. If traffic is going via fast Ethernet 24, what is the cost? 19. If traffic is going via 23, then what is the cost, guys? Here, you tell me, what is the cost? If traffic is going via 23, 38. 19 plus 19. So B to C and C to A, 19 plus 19, right? 38. So which is the best? Via 24 or via 23? Which is the best? 24. So port number 24 is elected as what? Root port. Now you tell me, guys, Ram, you tell me in switch C, which is a root port? 23 or 24? 23. Closest, nearest, right? So this is how elections. Root port elections is being finished, right? Root switch, root port. I'll go for designated port. Designated ports are very, very, very simple. Just we can write is designated ports are opposite of root ports. Opposite of root ports is a designated port. Port number 1 is a root port. Here, so it should be port number 1 is a root port, right? Which is opposite port? Other end is opposite. The cable other end is opposite. Quite opposite. Opposite port is what? Switch A, port number 1. This is DP, designated port. Let me come here. B24 is a root port. This opposite is a A23. A23 is a designated port. C23 is a root port. This opposite is what? A24. A24 is also what? Designated port. Opposite of root ports are designated port. Now all designated ports and all root ports are forwarding state. Finally, election between the B23 and C24. The middle have a one device. Data traffic now to reach the focal point of the network can go via 23 here to here and via 24 also here to here. Now cost is same. If cost is same, you'll go for why now what? Lowest port number 23, 24. Which is the lowest port number? 23. So 23 as a DP. and 24 is elect as what? Non-designated port, which is blocked by STP protocol. Designated port. Opposite of root port. Even designated port also will choose the same thing, like least cost, lowest neighbor switch ID, and physical port number. Designated ports will always be in forward state. Opposite of root port, designated port, designated port. Finally, port number 24 is being blocked by. So this is a task for to all of you to copy it, practice on this topology, and try to find out which is a root switch, and which is a root port, and which is a designated port, and which is finally which is a block port. A to B, this link is cost is 19. A to C, all the links cost is 19. So try to practice on this topology. Try to find out which is a root switch and non-root switches, root ports and designated ports, non-designated. Copy. What about the 4 points? Last point, non-designated port. Blocked by STP. So wait a minute. It is all about STP protocol. Let me see now some small facts. We don't need to configure any STP. STP is a default is enabled in all Cisco switches. Let me take one switch A, B, three switches connecting from switch A to B, and B to C, B to A. Now, if you see all LED colors in amber color, right, like orange color. You know why? But if you see the top, your setup here, you have some green, right? So once you connect the cable to become the green, it's taking some time, right? You know why? Because between the A and B, C, three switches, STP election process being happening now. So switch A and B, all the ports are going for listening state, are going for learning state, are going for forwarding state. So now all ports become the forwarded state. One port is still keeping it what? Amber. So that is being blocked by STP. Consider first one is A, B, and it is a C switch. Out of three switches, which is a root switch? A can be a root switch here. So A cannot be a root switch, right? Why? Because there is a block port there, right? Block port is there. So A should not be a block. A root switch. Now, either B, either C. So how we can check this, which is a root switch means log into switch and in switch your privileged user mode, privileged mode, use command show spanning tree, show spanning tree. Same command in the switch C also. Show spanning tree. Show spanning tree have a two ports, port number 1 and port number 2. Port number 1, role of the port. Port number 1 role is what? Root port. And state. Port number 1 state is what? Forwarded state. The cost of port number 1 is 1900 Mbps fast Ethernet port. If you go for port number 2 role is a designated port and state is forwarded and cost is what? 19. So switch C has a root port means it can be a root switch. Can be a root switch now here? No. So root port you can get in only which switches? The non-root switch. Non-root switch only we can get what? Root ports. Any switch with the root port means it's not a root. Go for B. The B port number 1 is designated. Port number 2 is also what? Designated. Like all are designated ports. So A, B can be a root. Here is showing the message here. This bridge is a root. I mean this switch is a root switch. Okay guys. Now switch A and switch B and C. Out of three, which is a root switch here now? Switch B is a root, right? Switch A, B, and C. So switch B is a root and A is a non-root. C is also what? Non. Now let's consider if switch B have purchased in 2015 have purchased switch B. And A and C have purchased in a recently in 2019. So V switches has a like high configuration. V switches has a high performance. AC switches or B switch? A and switch C, right? But now what STP is doing is STP is being elected as a visa route, which is in 2015 have purchased is a route switch. Is the focal point of the network. Is the main job head of the network. But switch B performance is low. 2015, like some protocols will not support. iOS version is very low. Older iOS version. So I don't want B is a route switch. I want to make A is a route switch. So because switch A is a recently have purchased a very advanced, like is a L3 switch. How we can make A is a route switch? So this switch you want to make a route switch. So that switch should be configured as a highest priority or lowest priority. So this switch have to make a route switch. That switch could be configured what? Lowest priority. Exactly. So instead of configuring lowest priority, we can define one command. Which switch you want to make a route switch? So that switch, if you define command, spanning tree protocol STP primary and switch B C if we configure spanning tree protocol secondary. Always switch A is now what? Route switch. Now configurations like a priority, MAC address, nothing, no need to change. Just define the primary command, that's it. Now A is a route. If A is fails, now B become what? Primary. Now B is a route, right? A is a block. Let me check in the switch A ports states. Show spanning tree. Port number 2. Alternate BLQ block port. In configuration mode, spanning tree VLAN 1, VLAN 1, let me give command root primary. Spanning tree VLAN 1, root primary. You can see the election started again. Concentrate on switch C. Switch A, two ports have become what? Green, right? Now C is a block. We have what? Check switch A port status. So spanning tree. Port number 1 is designated. Port number 2 is also what? Designated. Like we can change. This is a configuration. Spanning tree VLAN 1, root primary, or you can configure what? Second. So this concept, not only STP, we have RSTP, PVSTP, RSTP plus, PVSTP plus is very, very huge subject. So this STP protocol concept will covers under CCNA level, CCNP level, CCIE level also. Such types of STP, PVSTP plus, RSTP, RSTP, PVSTP plus, MST. like PV-STP plays are Cisco protocols. Even RSTP also Cisco protocol. Remaining STP, RSTP, MST, these all are what? Open standard protocols. So whenever 802 means is an open standard. Okay, clear guys? So your task is this is your task. So try to practice on it. And tomorrow I'll ask you the root and the non-root switches. So still we have some more terminology in the STP. Next session, tomorrow let me continue the same thing. Clear all of you? Any doubts? Hello? Yeah, any more doubts? No doubts, right? Thank you. Thank you for everyone and try to practice on this topology one by one based upon the parameters. You surely can get it. If you're not getting, you can message me in the WhatsApp. I'll help you out for that. Thank you. See you tomorrow at the same time.